In this video, we'll balance the net ionic equation for K2S plus PbNO3 2. This is potassium sulfide plus lead 2 nitrate. Let's balance the molecular equation first. So I have two nitrate ions here and just one here. So I'm going to put a 2 in front of the KNO3. Now I have two potassiums here, one sulfur here, that's good, and then one lead. So this is the balanced molecular equation. Now we need to write the state for each substance. Potassium compounds, very soluble usually, so we're going to put AQ. That'll dissolve and dissociate into its ions. Nitrates are very soluble, AQ. We have potassium nitrate here, that's going to be aqueous. But for lead, always be cautious with lead compounds. When we have sulfur bonded to transition metals, they are usually highly insoluble. So if it's insoluble, doesn't dissolve in water, it's going to be a solid. When these two react, it'll be a precipitate. It'll fall to the bottom of the test tube. So we have our states. Now we can split the strong electrolytes into their ions for the complete ionic equation. Potassium is in group 1 on the periodic table, and then sulfur, that forms 2 minus ions. So we'll have 2 potassium ions, and I won't write the states right now. Let's do that at the end. And then the sulfide ion, S2 minus. Lead, we can't tell just looking at it. It's a transition metal, but it's bonded to the nitrate here, which is always 1 minus. I have 2 of them, so it's got to be 2 plus. That's why we call this lead 2 nitrate. So we have our lead 2 ion, Pb2 plus 2 nitrate ions. And these are the reactants in our net ionic equation. For the product, we have, again, 2 potassium ions plus 2 nitrate ions. And then for the lead sulfide, the lead 2 sulfide, it's a solid. We don't split that up. We just write PbS. This is the complete ionic equation. Now we can cross the spectator ions out. They're on both sides of that complete ionic equation. I can see in the reactants we have 2 potassium ions, and in the products, get rid of that. 2 nitrate ions in the reactants, 2 in the products, get rid of that. What's left is the net ionic equation for potassium sulfide plus lead 2 nitrate. I'll clean this up and add the states in, and we'll have our net ionic equation. So this is the balanced net ionic equation for K2S plus PbNO3 2. You'll note that charge is conserved. We have a 2 minus and a 2 plus. They balance out. We have a neutral substance here in the product. And we have the same number of atoms on each side, so mass is conserved as well. Often you'll see the positive ion written first. Really doesn't matter, but some people like it that way. And that's it. That's our net ionic equation. This is Dr. B, and thanks for watching.